Hello guys, today my topic of discussion is X-linked dominant, X-linked recessive and mitochondrial inheritance diseases, and how you can recognize their category and how you will make the Punnett square of these diseases. So before going into the details of these diseases, I want you guys to know the very simple concept that you all might know before. So zygote is basically formed by the two gametes. So one gamete coming from the mother and one gamete coming from the father. So mother have XX chromosomes and father have XY chromosomes. These are the sex chromosomes. So now what is happening? The mother forms X and X gamete while the father form X and Y gamete. So if X combined with the X, you got the daughter, and if X combined with the Y, you will get the son. Now you will be think that why you are explaining this thing. So this is very important because we are discussing about the X-linked diseases. So let's say if this X in the mother is diseased or this X in the father is diseased, right? So now how these X's, diseased X will be transmit the diseases in the offspring in case of recessive pattern or in case of the dominant pattern. So here we only concern about the X chromosomes, right? Hope you understand this one. So now we talk about these diseases because before starting to this topic, I want you guys to know that in case of recessives, you have to mean that if you get an affected chromosomes, is the offspring will get the affected chromosome, he become carrier. He will become carrier of the disease in case of daughters. So recessive mean if it is if the X chromosome is in the recessive pattern, the daughter will become the carrier. I will tell you this later on when we go reach up to that topic. But in case of dominant, if you get the affected chromosomes, it will 100% show the disease, either it is male or either it is a female offspring. So that is the one difference, right? So in case of recessive pattern, the daughter will be carrier, whereas in case of dominant, whatever get the affected chromosomes will get the disease. Now come to the next topic. For the X-linked dominant, I want you guys to just remember this mnemonic, that is FDD. So what is that? Father, daughter, dominant, right? Again, I'm repeating FDD is what? Father, dominant, father, daughter, dominant. So what you have to remember in case of X-linked dominant disorder, father will be transmitted diseases to all the daughters. So all the daughters of the affected father in case of X-linked dominant will get the disease. So how can you remember? Just remember this, that you can normally know that father loves daughter more, right? Okay. So next, next the topic is next slide is about the how you make the X-linked dominant Punnett square, right? How you make the X-linked dominant Punnett square. So we will make a Punnett square in which mother is affected, but the way discussing about the dominant, right? In which mother is affected, and in one Punnett square when your father is affected. Now, how it look like? So this is the slide. You can see over here. So we are making one Punnett square in which in which the father is affected, and one Punnett square in which mother is affected, right? So come with the father affected. So this D stand for the disease chromosomes. Now, when this is combined with this one, you will get this, and XD this, and with this XY and with this XY. So this kind of a Punnett square you will get it. It's easy for you guys to make it. Once you make this one, you will get that I am talking about the dominant inheritance. So if the diseased chromosomes go into the daughters, right, XXD, all the daughters are affected. This is what I was telling, father, daughter, dominant. So that is the X-linked dominant inheritance, that the affected father will transmit the disease to all daughters. Now make the similar Punnett square by making the mother affected, right? So over here you see this XD is the defected chromosome in case of the mother. Now this is the category you will get. Now in this category, as we are dealing with the dominant disorder, so even the mother is affected. As I told you, in dominant, whatever son or daughter gets the disease chromosome, he will get the disease. So that is what they're saying. All sons and daughters have 50% chance of being affected because you are dealing with the dominant inheritance pattern. So what does 50% mean? That if a mother have two daughters, it will be chances that one daughter will be affected. If the mother have two sons, it will be chances that one son will be affected. That is what they are talking about, right? Now, how the pedigree will be look like. So this is the next slide which show you. Now you if you see this kind of pedigree in the U word or anywhere in your real deal. So if you see that the father is affected, let me get my pointer. So if you see father is affected and in the next pedigree, so this whole is your next pedigree. You see this one, this, this, and this, right? These are the next pedigree from this father. So if you see in the pedigree that the father is affected and all the daughters, so father affected and all the daughters are affected, then you uh, easily get know that you are dealing with FDD, that father daughter dominant disease. So then the next thing you have to know, this is the male and this next is the male. Let me remove this one. Let me use the reverse. Now you can see that this is the male affected person, but it is not transmitted disease to the other males. So there is no male to male transmission. So in case of X-linked dominant diseases, you don't have male to male transmissions. So why it is that? Because this male, it might have, let me write over here, it might have this X disease, right? This male have might this disease chromosome and this Y, right? So it will give Y to the boy, right? This Y will go to the next generation, not this disease X, right? That's why I have written because father gives only Y, not X. So in case of X-linked dominant or X-linked recessive diseases, there is no male to male transmission. So up to here, you just remember that in case of X-linked dominant, no male to male transmission, right? Because father, affected father only give Y to the son, not the X. So that is the story about the X-linked dominant. Now come to the X-linked recessive. So in case of X-linked recessive, you simply remember the mnemonic again, MSR. So what is MSR in case of X-linked recessive? Mother, son, recessive, right? Mother, son, recessive. So what does that mean? Now the affected mother will give disease to the son, right? So that is how you can remember. Again, mnemonic wise, mom loves the sons more, if it is applicable for you guys, right? Okay, so now again, you will make the X-linked recessive Punnett square, right? One with the mother affected, one with the father affected. Now over here, we are dealing with the, again, I'm pointing, we are dealing with the X-linked recessive. So pay attention towards this one. So this is how you will get the Punnett square against the first Punnett square I make over here. That is your X-linked recessive when your father have the disease, right? Have the disease of the carrier, and your mother is normal. So this is how you get the Punnett square. But what will be that father will give X disease chromosomes to the daughters. So what will all daughters are carrier? That is what I explained you earlier. That recessive mean all the daughters will be carrier, right? All the daughters will be carrier. So now all the sons are unaffected, right? Again, the same thing that fathers are giving Y chromosomes to the boy, right? So you understand this one. So and why the daughters are carried in case of recessive, as I told you, because they have one normal chromosomes. So this one is the normal, which is coming from the mother. So which can counteract the effect of the disease chromosomes. That why the daughter becomes carrier and not affected, right? Now what is happening in case of mother have the disease chromosome in case of X-linked recessive inheritance. So this is the Punnett square you will get, right? Over here, what is your daughters have 50% chance of become carrier. Again, one is the disease chromosome coming from the mother, and this chromosome X is coming from the father. So what is happening? The normal chromosomes counteract the effect of the disease chromosomes, so the daughter will become carrier, right? And what is happening in case of the sons? Sons have 50% chance of being affected. Again, the mnemonic MSR, mother, son, recessive. That is what this disease chromosome is going, is contributed into this male, while the Y is coming from the father. Now this son have the disease chromosomes. That's why in case of X-linked recessive inheritance, affected mother transfer the disease to the son, right? About the carrier, I told you the same explanation as I given you the above. But in case of son, you will be affected, right? Because there is no other normal X chromosome, because Y is not counteract the effect of this one. So in case of X-linked recessive inheritance, the affected mother will give the affected son. Affected mother give rise to the affected sons. So now how this pedigrees look like, here you go. You can see, so if in the actual day you see that the female, so this round is female and this square is for the male. So if female have the first pedigree in which all the males are affected, you see all the sons are affected. So you can see this is M, which is your mother affected, and all the sons are affected, and this is autosomal recessive. This is how can you diagnose the actual pedigree in the U word or the real D. Again, no male to male transmission, which I told you earlier, that males, they are only given the Y chromosome, right? Not the X chromosome, right? So that's why no male to male transmission. So one thing, in case of X-linked dominant or in case of X-linked recessive inheritance, there is no male to male transmission. In case of X-linked dominant, father's daughter dominant, and in case of X-linked recessive inheritance, mother's son's recessive. So this is how the pedigree look like. This slide I especially make, you can see that the Punnett square is the same, right? Punnett square is making the same way, but the only thing you have to pay attention that in case of dominant inheritance, you will be having the all daughters are affected. In case of your father is affected, affected father have all the daughters affected, while the sons are unaffected, and affected mother have 50% chance of being affected because it is a dominant inheritance, so both will be affected, right? In case of, and this is the pedigree, male, this is the father, and all daughters are affected. So this is, let me write over here with you guys so you can then remember. This is FDD, father, daughter dominant, and over here you can see this is the mother and all sons are affected. So this is mother, son, recessive. So this is how you look like. So this is how the pedigree are showing. So next is, this is the overall. You can see this is how the examples are giving in your U-word questions and you have to diagnose. So this is the, now you can tell me that if this male is affected and all daughters are affected. So what is that? Exactly. This is FDD, that is father daughter dominant. Now, in this case, female is affected and all sons are affected. What is this? MSR. Exactly. Mother son recessive. Now, the last one is mitochondrial inheritance. Mitochondrial inheritance is very simple to diagnose. What if the mother have the mother is affected? Simply, if the mother is affected and all the kids have the disease, so that is you're dealing with the mother in mitochondrial inheritance. And male cannot transmit to the disease. Why? Because sperm don't have mitochondria. So this is the pedigree you will see in the U word also. So what is here? You can see this is the mother, right? So what is this mother have? These two kids, you see. So these two kids are affected, right? Now this mother, when it's get married to another person, it will have three kids and all are affected. So this mother will give affected kids and this mother will give the affected kid. So this is simply you can diagnose that you are dealing with the mitochondrial inheritance. The last point, father cannot transmit to the disease to the offspring, right? Why? Because the sperm don't have mitochondria. That is all. That's all for the today's session. So next I will explain about the autosomal recessive and autosomal dominant disorder. Thank you so much.